Alright guys, so today we're going to learn a new chapter, the conservation law of physics. So, before we learned the Newton's three law, right? And we learned the object's motion. So momentum is just another way of looking at how objects affect each other's motion, rather than looking at how forces change over the time of the interaction. We can look at how objects are moving before they interact and then after they interact. So we have two terms. One is momentum and one is impulse. So I I'm pretty sure you heard momentum many times before. So imagine if a bowling ball and a ping pong ball are each moving with a velocity of 5 meters per hour. You intuitively understand that it will require more effort to stop the bowling ball than the ping pong ball because of the greater mass of the bowling ball. Similarly, if you have two bowling balls, one moving at 1 meter per hour and the other one moving at 10 meter per hour, you know it's going to take more effort to stop the one with faster speed, right? So it's clear that both the mass and the velocity of a moving object contribute to what is necessary to change the motion of the moving object. Just like it's moving, you have to make it stop. So the product of the mass and velocity of an object is called the momentum. Momentum is a vector quantity that has the same direction as the velocity of the object and is represented by lowercase p. Here, in this lecture, I have things underlined or highlighted. Please write down on your notes. So those are the ones I will be testing you on your quiz. Okay? So we have a formula. P, the momentum, equal m times v. Somehow I cannot highlight the formula, so make sure you write down the formula. Okay? Which is very simple. For example, you have a question. The momentum of a 0.5 kilogram ball moving with a velocity of 15 meters per second will be, you write your given, m equals 0.5 kilogram, and your velocity, v equal 15 meters per second. So your standard unit for momentum is kilogram times meter per second. Okay? You multiply them, you get your answer. Let's take a look at this video explaining further about momentum.
Hi, it's Mr. Anderson, and this is AP Physics Essentials video 49. It's on momentum, which is just the product of the mass of an object times its velocity. In 1895, a train was headed towards Paris. They were a little bit behind schedule, didn't apply the brakes in time, and it came shooting out through the train station. What was their problem? They had too much momentum. And if you were to ask somebody, what is momentum? They'll probably come up with a pretty good definition that would fit in physics. Momentum is always going to occur if we have an object that's in motion. And if you want to calculate it, you simply multiply the mass of the object times the velocity of the object. The greater the mass, the greater the velocity, the greater the momentum is going to be. And so if we want to change our momentum, what could we do? Well, we could decrease the mass, we could increase the mass, or we could change the velocity. What's the easiest way to change the velocity is to apply a net force to that object. If we apply a net force to the right to this object, what are we going to see? We're going to see an increase in momentum towards the right. Let's say the object is moving towards the right and we change the net force on the object. What's going to happen? It doesn't happen instantaneously, but what we'll see is a change in momentum that reflects that net force. And so if we define momentum, the equation is P equals mv, where we're multiplying the mass of an object times the velocity of the object. So if we have this cart here, 1.0 kilogram cart, and it's moving with a velocity of 2.0 meters per second, figuring out its momentum is really easy. You simply multiply 1.0 times 2.0, and so our momentum is going to be 2.0 kilogram meters per second. And so if we add velocity to the right, we're going to increase that momentum. Now, one thing that you need to remember is that the net force on an object is going to affect that change in P, or that change in momentum. And so let's say we have an object like this, a cart that's at rest. It has no momentum, but we apply a net force to it. How would we do that in a physics lab? We're just going to connect it to a weight. And so now we're going to apply a net force to the right. What's going to happen to our momentum? It's going to increase to the right. What happens if we increase that net force? If we double the net force on the object, what's going to happen? We're going to increase the momentum more quickly. Let's say we triple it, we're going to see an increase in momentum to the right. And so it's a direct relationship between the net force on an object and the momentum on that object. But let's make it a little bit trickier. Let's say that object is moving now towards the left, but we're applying a net force to the right. What's going to happen? Well, eventually what's going to happen, let's watch, is it's going to slow down, and then it's going to start to accelerate to the right. And so even though it was moving to the left, as we apply a net force to it, eventually that momentum is going to move in the direction of the net force. Now, these are pretty easy problems because we're just looking at one dimension. But when you were growing up like me, you probably played video games like this. And so if I turn the ship and move it in this direction and blow up an asteroid, it's all momentum. But I would find myself playing asteroids like this. I'd be moving in one direction, but I'd be applying a force in another direction. In other words, my momentum is in that direction, but my net force is in a totally different direction. What's going to happen to that? Well, it doesn't happen instantaneously, but what's going to happen is that ship is eventually going to move in the direction of the net force. And so did you learn to justify the data we need to collect to show that the net force eventually impacts the change in momentum? I hope so, and I hope this was helpful.
All right, so basically he explained what I just told you, right? It's pretty simple. Momentum is mass times velocity. However, it does introduce a new concept that net force will change the overall direction and velocity of an object. So before we get into that, don't stress out about it. We're going to talk about the net force. We're going to talk about the change in momentum in a moment. But here, I want to address a misconcept that, according to Newton's first law, the velocity of an object cannot change unless a force is applied, of course. If we wish to change the momentum of a body, we must apply a force in the opposite direction or in different direction, right? The longer the force is applied, the greater the change in momentum. So imagine you're stopping a cart. So if you apply the same kind of force for just a second until the car stopped, so it just stopped right there, right? But if you, after you stop, you keep applying, it takes longer time to applying the same kind of force in a different direction. Of course, the car will change direction and go the other way and getting faster and faster, right? So that's what it means. The longer the force is applied, the greater the change in momentum. A common misconception is that when two objects collide, the smaller object is hit harder or experiences more forces than a larger object, which is, since it's a misconception, which is wrong. Why it's wrong? Please work on can you bump your friend's car harder than she bumped yours? The bumper car activity, I connected the link in the lecture. Try that and figure out yourself why it's wrong. All right, so in the video earlier, we talked about, he talked about the change in momentum, okay? So that introduced us a different concept called impulse. So the impulse is a quantity defined as the force multiplied by the time that it is applied. it is a vector quantity that has the same direction as the force. So we know for the okay, so here the unit for the impulse is Newton times Newton, which is force, times second. But we also know that Newton can be written as kilogram, because F equal ma, kilogram times meter per second squared. So the impulse can be written as Newtons times second or kilogram times meter per second. As you noticed, kilogram times meter per second is the same unit as momentum. Okay, so basically, impulse is the same as momentum, but it's the change in momentum. Okay, since it's a change, the unit does not change. It's just a number change. So when an impulse is applied to an object, the momentum of the object change, and the change in momentum is equal to impulse. So don't get two things confused. Sometimes, in order to find impulses, you have to find the momentum first. Or in order to find momentum, you have to find impulse. Okay? So the impulse is force times time. F times t is also equal to change in momentum. Momentum is mv, right? So delta means change. Okay, so delta mv. Basically, when you write delta mv, it's really the final momentum subtract the initial momentum. Okay, let's take a look at this video then. You know what? It's too long. You can watch it yourself. Okay, so here are example 1, 2, and 3. They're pretty straightforward. I would like you to read them and then just work them out. Okay. So that let's look at the summary. So summary, today, the product of the mass and velocity of an object is called momentum, given by the equation momentum equal m times v. Momentum is a vector which has the same direction as the velocity. The quantity of a force times by the time is called impulse, and impulse is also the change in momentum, which is final momentum minus initial momentum. It has the same direction of the applied force. And both momentum and impulse have the same unit, kilogram times meter per second. And once you're done writing these notes down, what you need to do is go ahead, do the exit ticket, make sure you write your answer with 3 significant figures and correct units, and then your homework is the worksheet with 10 problems. Okay, I'm going to demonstrate your homework and go into more detail, explain the word problems more further in next lecture. Have fun!